We are still looking at using trig identities to simplify trig expressions. We're going to add another strategy today to our 5, and we're going to look at 2 more identities. So far, how many strategies do we have?
5.
We have 5. Today we're going to add 1, so we're going to have a total of 6. Alright, so number 1 was common denominator, correct?
Can we just add it on to the one?
No, because it needs to be in front of 6. So common denominator, what was number 2? Factor. What was number 3? Number 4?
Fraction.
Alright, that's where we're going to put it. We're going to put it at number 4. Okay, and the new one today is multiplied by conjugate. Okay, so multiply by the conjugate is another strategy we're going to add in there. First problem, I have cosine squared over 1 minus sine. Cosine squared over 1 minus sine. So we're going to use our trig identities to simplify this trig expression. So I still go through my list. Do I need a common denominator? Is there anything factor? Is there a Pythagorean? No. So then we get to multiply by the conjugate. In this case, we do want to multiply by the conjugate.
How is there not a Pythagorean?
What do you say the Pythagorean is? Cosine squared is okay. Now, here's the deal. You usually only want to use a Pythagorean if we have 2 things being added or subtracted. You usually want to go from from big to small. You don't want to go from small to big. So if I was going to replace cosine squared, it would turn into 1 minus sine squared. So I would take something that is small and turn it into something big. So I usually want to go from big to small. Okay? Now, like I said, there are many ways you can do this. Actually, you can get to the same answer by using your identity that you're talking about, but that's not the way I want you to do it in this case. Okay? And like I said, I prefer you follow. If you're having trouble, you need to follow what I'm doing up here. You need to follow my method. If you feel comfortable with it, then you can explore and find different ways to get the answer. But this is the guaranteed way to get there. So, what we should notice is that 1 minus sine is what I call a half of a conjugate. What is the other half of the conjugate? 1 plus sine. So, whenever you see half of a conjugate, the strategy we can use is multiply by the other half of the conjugate. So, in this case, it would be multiplied by 1 plus sine of x. Okay, so cosine squared over 1 minus sine and multiply by 1 plus sine of x. Now, here's the deal when you multiply by the conjugate. You only want to distribute on the part where you're doing a conjugate times a conjugate. So that means I do not want to distribute in the numerator, and you'll see why here in a second. So the numerator I want to stay as cosine squared equals 1 plus sine. The denominator I'm dealing with conjugates, so we go ahead and multiply that out, and we end up with 1 minus sine squared. Okay, now we see what do we have that we can do. Now we have a Pythagorean where I can take something big and turn it into something smaller. So I end up with cosine squared 1 plus sine over cosine squared. So now hopefully you see why we didn't distribute. Okay, why did I not distribute? Because something's probably going to cancel as long as I don't distribute. So the cosine squareds cancel, and we end up with 1 plus sine of x. Now, how do I know I'm done when I get to 1 plus sine of x?
You can't do it.
I can't do any of those 6 up there on the board. Okay. Next one.
So if you end up multiplying by a conjugate, like your answer will be
Okay.
That would be convenient.
That would make math too easy.
Okay, on the next one, I have 2 times sine over cotangent plus cosecant. 2 times sine over cotangent plus cosecant. So again, we go through our list. Do I need to get a common denominator? Is there anything I can factor out? Is there a Pythagorean?
No.
Can I multiply by the conjugate? Yeah, if I've got a binomial, that means I can multiply by a conjugate. So what is the conjugate? There you go. So it would be cotangent minus cosecant. So my numerator, do I want to distribute in the numerator? No, I want to leave it as 2 sine of x times cotangent minus cosecant. The denominator, I'm dealing with my conjugate, so I do want to multiply it out. So I have 2 times sine of x times cotangent minus cosecant over cotangent squared minus cosecant squared. So, can I get a common denominator? Can I factor anything out? Do I have Pythagorean? Yes, but I don't have an exact match. What is a Pythagorean that is close to cotangent squared minus cosecant squared? Cosecant squared minus 1. And what is cosecant squared minus 1 equal? I mean, sorry. You fooled me. I thought you were going to say the right thing. What's close to cotangent squared minus cosecant squared?
Cosecant squared minus
Cosecant squared minus cotangent squared, and what does that equal? 1. So what is this one going to equal? Negative 1. And I'm going to go ahead and move it to the top. So, can I get a common denominator? Is there anything I can factor out? Is there a Pythagorean? Can I multiply by the conjugate? Technically, I can, but if you multiply by the conjugate once, you don't want to do it again. Because if you do it again, then you just undid what you did. Is there a fraction in a fraction?
No.
So that means I want to do what? Convert. So I have negative 2 sine of x times cosine over sine minus 1 over sine. So what do I want to do next? Yes, Rachel.
How were you able to move the negative?
Because it just turned into negative 1. My negative 1 can go anywhere I want. So I just move it to the top. Gage, what do you think we want to do next?
Can't the cosine over sine and the 1 over sine go into each other?
Very good. So that gives me cosine of x minus 1 over sine of x. I got 2 fractions. Put 2 fractions together. Yeah, they've already got the common denominator.
minus 1, and then it just be sine.
And now the signs can cancel.
Okay, that's good.
And I'm left with negative 2 cosine of x minus 1. I can distribute the negative 2 if I wanted to. Am I done? How do I know? I can't do any of those 6. There's no common denominator. I don't need to factor. There's not a Pythagorean. I don't want to multiply by the conjugate. There's not a fraction in the fraction, and there's nothing left to convert. That tells me I'm done. All right, one more of these before we get to our new identities.
What?
Oh, okay. Oh, I didn't know which one I was like, what? Yeah. Nobody.
Okay, sine of x tangent of x over cosine of x plus 1. Sine of x tangent of x over cosine of x plus 1. So, common denominator, factor, Pythagorean, Do I have a binomial that I can multiply by its conjugate?
Yes.
Yes.
Yeah.
So the top is going to be sine of x, tangent of x, parentheses, cosine of x, minus 1. The denominator is cosine squared of x, minus 1. So, do I need a common denominator? Can I factor? Is there a Pythagorean?
Yeah.
Yes. Do I have an exact match? No. What can I replace cosine squared minus 1 with? Negative sine squared.
Yeah.
I can cancel that sign with one of those signs on the bottom. There's that. So now what?
Six one.
I'm hoping he means convert.
Yeah, that one. You know.
Wow.
Wait. Oh, okay. I see what
So now which one of my 6 do I have? I've got a fraction and a fraction, so I multiply by cosine over cosine. Now remember,
Oh, that's
my whole numerator is what? 1 unit. Why is it 1 unit? They're being multiplied. So since they're one unit, that means that I've only got to put this cosine in here one time, which is going to cancel. Okay, and in the bottom, does anybody see anything else that can cancel at this point? The signs can cancel.
Okay.
Because once this cosine is gone, then we can see that these signs can cancel as well. So that means I'm only dealing with cosine of x minus 1 over negative cosine of x. Anything else I can do? Bobby?
Can you get the negative out or no?
I can move the negative up if I wanted to, or I can move it out front if I wanted to. And Bailey, I know you weren't saying that you could cancel the cosines. You weren't saying that, right?
I was thinking that.
Why can't I do that, Kendrick?
Because they don't factor out.
I can't, yeah, if I can't factor it out, I can't cancel it.
So if you can't
Yeah.
So if I have stuff being added or subtracted and I can't factor it out, then I can't cancel. Stuff has to be multiplied to be able to cancel. Okay, that's why I'm able to cancel these two. Why am I able to cancel these two?
Because it's being
Because it's being multiplied times this. Okay, if it's not being multiplied, you can't cancel it. Okay, so at this point I'm done. I can't get a common denominator. I can't factor. I can't do a Pythagorean. I can multiply by a conjugate if I wanted to, but I don't want to because I've already done it.
Yeah.
There's not a fraction in a fraction, and there's nothing left to convert, so that means I'm done with that problem. All right, 2 new identities.
I got no more.
Negative angle identities. All right, these are pretty simple and pretty useful. Okay, the negative angle identity says if I have sine of a negative angle, it is the same thing as a negative sine of the positive of that angle.
What?
If I have sine of a negative angle, it is the same thing as a negative sine of that angle. So, for instance, here's an example. Okay, this negative angle identity is telling me that sine of negative pi over 3 should be the same as what?
Negative sign.
negative sign of pi over 3. So that means if I evaluate this on the left, it should give me the same as what's on the right. So let's figure this out. Since I'm dealing with a regular sign, what two things do I need? Reference angle and quadrant. What's my reference angle? 60 degrees. What's sine of 60 degrees? Square root of 3 over 2. And it is in the fourth quadrant, and my letter in the fourth quadrant is C. So that means this needs to be negative. So this side's pretty easy. Here's the negative, so I know it's got to be negative, and now all I have to do is evaluate that. We know sine of pi over 3 is square root of 3 over 2. So as you see, sine of a negative angle is the same thing as negative sine of the positive of that angle, and we get the same answer. Okay? So, sine, obviously cosecant is going to go with sine, so the same thing is going to happen. Cosecant of a negative angle is the same thing as a negative cosecant of the positive of that angle.
That applies.
Oh, she was writing down that problem. She got the book before.
Okay. Now, cosine and secant are the ones that are different. Cosine of negative theta is the same thing as cosine of theta. The negative goes away. Okay? So to see an example of that, let's do the same thing. Negative pi over 3 and cosine of pi over 3. So the negative angle identity says that these two things should be equal. Again, I need a reference angle and a quadrant. So my reference angle is pi over 3. What's cosine of pi over 3? 1/2. What quadrant am I in? I'm in 4. What's my letter? C, which means this is positive. And over here, all I need is cosine of pi over 3, which we already said was 1/2. So I have 1/2 equals 1/2. So on cosine, the negative goes away. So that means secant is going to do the same thing. The negative is going to go away on secant. So secant of negative theta is the same thing as secant of theta. So then that means we need to look at tangent. What do you think is going to happen to tangent?
It's gonna become negative tangent of theta.
Very good. It's going to be negative. And same thing for cotangent. So this makes dealing with negative angles a lot easier. Okay, either you're going to pull the negative out or the negative's going to go away. And after you do that, then all you have to worry about is the positive. Okay, but the key to remember it is cosine and secant, the negative goes away, everything else, the negative comes out. So that is negative angle identities. Question on that? Next one. Cofunction identities. Cofunction identities. That means that there are functions that are cofunctions of each other. What do you think the cofunction of sine is? That's how you spell sine. S-I-N-E. What is the cofunction of sine? What is the cofunction of sine? Cosine.
What the heck?
What?
is this? It's too simple.
Yeah, that was your trick.
It's too simple.
What is the cofunction of secant?
Cosecant.
Cosecant. So obviously the cofunction of tangent is
I never knew how to spell that.
cotangent. Okay. Now, that's pretty easy to figure out. What are cofunctions of each other? The trick is, how are cofunctions related? So that's the next thing we want to discover. Is how are these things related? So I'm going to give you some examples, and I'm going to see if you guys can come up with what the relationship between a function and cofunctions are. Alright, what does sine of 60 equal? Square root of 3 over 2. What does cosine of 30 equal? Square root of 3 over 2. What does sine of 30 equal? 1/2. What does cosine of 60 equal? 1/2. What does sine of 45 equal? What does cosine of 45 equal? What does sine of 0 equal?
No.
0. What does cosine of 90 equal? 0. What does sine of 90 equal? 1. I mean, sorry. Yeah, that's right. What does cosine of 0 equal? 1. No. I just wanted you to look at it. And now, I want you to see the relationship between a function and its cofunction.
I see.
Flip.
They're equal when something has to be going on. There it is.
Oh.
60 and 30, 30 and 60, 45 and 45, 0 and 90, 90 and 0. So cofunctions are equal to each other when their angles add up to 90 degrees. So that means sine of 15 degrees is equal to cosine of 75.
Okay.
Is that always true?
It is always true. Cofunctions are equal when their angles add up to 90 degrees. So if I tell you that sine of theta is equal to 2/9, if sine of theta is equal to 2/9, cosine of what is also going to be equal to 2/9? 90 minus theta. Now, what could I use? What could I also use instead of 90? Pi over 2. So, if I know what a function is, I automatically know when the cofunction of it equals that same number. Okay? So, let's write these down. So, sine of theta is going to equal to cosine of what? 90 minus theta, let's use pi over 2 minus theta. Cosine of theta is going to be equal to sine of pi over 2 minus theta. Secant of theta is going to be equal to cosecant of pi over 2 minus theta. Cosecant of theta is going to be equal to secant of pi over 2 minus theta. You can, as long as you understand it, you're good to go. If you need to write it down, write it down. It just depends on what type of person you are. If you need it in front of you to understand, then write it down. If you've got it upstairs and it makes sense to you, then don't write it down.
I'm not sure.
Everybody done writing it down? Who wants to write it down?
That's professional to lead a 7.
You got it, Hunter? Alright, let's do a couple examples. Whoops. I don't know what I pushed. Alright, so let's say tangent of theta is equal to negative 3.754. What is cotangent of pi over 2 minus theta going to equal? Negative 3.754. So that's pretty easy. Now let's put one in that also requires us to use the negative angle identity. Oops. So this time they're giving me cosecant of theta is equal to negative 1.24, and they want me to find secant of theta minus pi over 2. What is a little bit off on this problem? Pi over 2 and the theta are switched. So if cosecant equals negative 1.24, what do I know also equals negative 1.24? Secant of pi over 2 minus theta. So that's always good to write down. Okay, I also know that. So what that means is I want to do some manipulation to this to help me figure out what this one is. So what type of manipulation do I want to do this, do you think? I want to switch these two, and if I switch these two, what do I have to do? I got to change the sign. So what I'm going to do is I'm going to do secant of negative pi over 2 minus theta. So if I switch the order, I got to put a negative in front. Okay? Now, here's where your negative angle identities come into play. What do I do with a negative that is inside of secant?
Goes away.
It goes away. So that means this right here is the same as secant of pi over 2 minus theta. So that means my original problem, secant of theta minus pi over 2 is equal to negative 1.24. Because what have I proven here? What have I proven here between these two? They're the same. But yeah, it's going to be different on different. We'll do another problem to show you how it's going to be different. Okay? So what you do is you write down what you know. Then you want to manipulate it to where you end up with pi over 2 minus theta. Sometimes the negative is going to be in front. Sometimes the negative goes away. And then that tells you what it is you're trying to find equals. It'll make more sense on the next one. Hopefully. Whoops. Alright, so on this one they tell me that tangent of theta is equal to 1.52. They want me to figure out what cotangent of theta over theta minus pi over 2 is. Okay, if tangent of theta equals 1.52, what else do I know? Very good. So write down what you know. So I know this right here is equal to 1.52. So now what do I want to do to cotangent of theta minus pi over 2? Switch it. So cotangent, put a negative in front of it, pi over 2 minus theta. Now what do I want to decide? Does the negative go away or does it come out front? It goes out front. Okay, so what is it that I have just proven? This is the same thing as this. And what do I know that is equal to 1.52. So that means cotangent of theta minus pi over 2 is going to be equal to negative 1.52.
Okay.
So that's how you work those problems. Write down what you know, change the order, figure out what to do with the negative, and then figure out what your answer needs to be. Yes.
Will we always use 5 or 2?
Yes. And the only other thing it could be is 90. It's either going to be pi over 2, it's going to be 90.
So if you use 90, it's the same.
It's the same process, except you'd have 90 where it's pi over 2.
Yeah.
What is the 1.5? Never mind.
So ask the question because you might be thinking.
Yes, there is.
Alright, so our new strategy. What's our new strategy that we can add to our 5 that we already had? Multiply by the conjugate. Our 2 new identities are negative angle identities and co-function identities. On the negative angle identities, when does the negative of the angle go away? Cosine and secant. Everything else, negative goes out front. On co-functions, when are co-functions equal?
When they are complementary.
When their angles are complementary. So if I know cosine of 25, that means I also know
No.
sine of 65. So cosine of 25 and sine of 65 are the same thing. That's what's going on with co-functions.
Jesus. Where are you? Obviously. Obviously. You always come
Alright, page 317, 18, 20, 21, and then 38 to 46.